Welcome to a short lecture on inventory costs. I am going to go over why do we need to calculate inventory costs in a logistics course, how to do that using an Excel workbook that I have built for you to use, and some additional points that may help you use this analysis in your cases or exams and so forth. Now, this short lecture assumes that you have studied inventory management in a prior course, either operations or supply chain management. If you've never studied inventory management before, then I have a full recording of this entire detailed slide deck that I'm showing you here with 41 slides that I explain slide by slide on what these formulas mean. But I believe if you have background in inventory management, a lot of that will be very repetitive for you, boring for you. So I'm gonna do a short refresher and what you need to know for the logistics course. If you have the background, you need to understand the formulas obviously, but if you don't have the background, then please watch this lecture first to get the overview and then go watch the detailed recording of this entire slide deck as well. Okay, so we want to calculate inventory cost under different scenarios because the decisions we make in logistics are going to impact inventory costs. Okay, and so if you need to make a decision that impacts inventory costs, people are going to ask you, okay, that's going to increase or decrease the inventory cost, how much? And so you have to be able to explain how much and why. Right? So sometimes students throw up their arms and say, oh, why do I need to see some formulas? Which in this case is only partially true because the formulas are all built into this Excel file. And so you don't need to see the formulas, you just need to know how to use this file while having an understanding of how the formulas work. But you don't need to, take out your TI-89 and do stuff by hand. Okay. So the main reason being, a lot of decisions in logistics are going to increase or decrease your inventory costs, and you need to calculate by exactly how much. Okay, so I'm assuming you know what inventories are, why we have them, all of that nice stuff. This is basically what is our focus today. Okay, to calculate total inventory costs in dollars per year for either one item, one SKU, or a group of items or group of SKUs. Okay, and when we talk about the formula, I'll talk about, how can we use it for a group. But basically, our total inventory costs in a whole year are going to be based on four different things. All of this analysis kind of assumes a certain supply chain setup. Okay, a simple supply chain setup that I'm going to show you right here. Okay, so what we're assuming is we have some facility right here, like a warehouse. Okay, and we have a supplier, and we order from the supplier on the right hand side. A certain number of units. We pay the supplier C naught. This is the price we pay the supplier per unit, dollars per unit. The supplier ships, or we, arrange for transportation, and the stuff is shipped, trucks, trains, ships, whatever the mode is, to our warehouse or retail shop or our facility. We pay our dollars per unit to the transportation company, and then when we receive the goods at our facility, their cost at this location is called landed cost, or C, which is C naught plus R. So let me give you an example. Let's say, I'm buying shoes and each pair of shoe cost me $30. So C naught is $30 that I pay to the supplier. Okay, then I look at my transportation charges, whatever a whole truckload or container load costs, I divide those charges by number of units transported to get a per unit transportation expense. So let's say I spent $2 per unit in transporting the shoes from the supplier to my warehouse. So at my warehouse, the landed cost per unit is going to be $30 paid to the supplier plus $2 paid to the transportation company, or a total of $32 per unit is what it costs me to receive product, what product costs me at this point in my supply chain. So for this sort of a setup, we are going to calculate the inventory costs at this warehouse. Okay, it could be a warehouse, could be a retail store, could be anything like that. Okay, and so we're going to do this for a simple setup. Now obviously if you have multiple suppliers, you can use the formula multiple times to calculate total cost for each SKU that you get from each supplier. So you can always apply this formula many times to each SKU for each supplier, and get the inventory cost for that SKU. Or if one SKU is a double sourced or multiple sourced, where you have 3 suppliers or 2 suppliers shipping the same SKU to you, then you can take the average price you pay to the suppliers as C naught, the average transportation rate as R, and kind of just club the 3 suppliers into a big virtual supplier and assume you have this one supplier base or something, and then all the product flowing to your warehouse, you can calculate the inventory cost here for all of that entire product volume that comes from those 3 suppliers. Okay, now we are going to look at demand attributes of the items to calculate inventory costs, and demand is different for different SKUs. So usually the analysis I'm going to show you, we will do it for each SKU separately. Although we can always make a combined or average SKU, which I'll talk about later if you want to do the analysis in one go for a group of SKUs. So anyway, this is a supply chain setup. We're going to calculate the inventory cost in our warehouse or retail shop. We're going to have suppliers shipping us stuff. We're going to pay a transportation rate, right? And we're going to pay something to the supplier for the stuff they ship us. So simple setup. Okay, but very flexible. You can model a lot of situations with that setup. So in that setup, the inventory cost in our warehouse or retail store, whatever our facility is, are going to be a sum of 4 different types of costs. The first one is called carrying costs. This is also called holding cost. So this is the cost to store product over time. Why you have to pay rent, you have to pay utilities, your money is invested. There's opportunity cost to have money invested in inventories. All of that adds up to cost to store stuff or carry stuff for over time. Okay. The second is ordering cost. We're going to have some ordering cost when we order stuff from the supplier. Then we're going to have out of stock cost. Unless we carry infinite amount of stock, sometimes we will have demand spike up and it will cause lost sales. So the out of stock costs are basically the cost of lost sales when we don't have inventory and the customer comes knocking and says, I want to buy 10 units, and you say, I can't sell you 10 units. So you have an out of stock cost. And then we have pipeline inventory costs, which is the cost of inventory when it's being transported from the supplier to our facility. Because when something is on a transport, whoever owns the inventory still has money invested in the inventory, and so there is a cost they incur, kind of like a holding or carrying cost, but this is like a carrying cost for only the time period when goods are being transported from the supplier to our facility. Once we calculate these 4 costs and we add them up, we get total inventory costs in dollars per year. The units of each of these 4 parts also happens to be dollars per year. So carrying cost we calculate on an annual basis. How much does it cost to carry inventory of this item for 1 year? Ordering cost is also on an annual basis. Out of stock cost annual basis. The formulas are designed to calculate each of these on an annual basis. So the final number you get is the dollars per year you spend on inventory for a particular SKU. Okay. Okay, so now let me show you. Now, obviously, if you have no background in inventory, you never took operations management or you totally forgot it, you can read these slides about what inventory is, why it goes up and down. You can go over the detailed lecture which talks about this, all of this, okay? So I'm just going to go to the final conclusion, which is the final formula. So total inventory costs in dollars per year, the total cost to us, TC, total cost equals, it's the sum of 4 rectangles, these red rectangles. The first rectangle calculates the ordering costs on an annual basis, dollars per year. The capital D is annual demand. So whatever SKU we're looking at, how much do we expect to sell in 1 year? S is the ordering cost in dollars per order. So whenever you place an order for this item with your supplier, what is the cost of placing that order? Q is the order size or batch size. So whenever you order from the supplier, do you order 1,000 units? Do you order 2,000 units? Do you order 10,000 units? That batch size or order size is going to be Q. Now, in some situations in real life, we may order different amounts at different times of the year. Summer may be a lean period, we may order less. Winter may be a high season, we may order more. In those cases, you want Q to be the average Q. So on average, what's your batch size that you order from the supplier? D over Q gives you the number of orders in a year, multiplied by the cost per order S gives you the total ordering cost per year. The second rectangle computes the carrying cost, which is also called the holding cost. Okay, so this is also known as the holding cost. So you might see that term. Okay. Now this formula, how does it come about? You have to listen to the detailed lecture, but essentially H is the percentage holding cost. So if H is 20%, that means that 20% of an item's value is spent to hold that item in our warehouse for 1 whole year. C is the landed cost of the item. So if H is 20% and C is $100, 20% of $100 will give us $20. So for an item that costs $100 in terms of landed cost, we will spend $20 to hold 1 unit of that item in our warehouse for 1 whole year. Then we multiply in the parentheses, we have the average inventory level. So Q over 2 plus Z multiplied by standard deviation of demand during lead time, SDL. All this is called the average inventory level. Okay. Again, refer to the detailed lecture if you don't understand what this means. So this is how we can calculate the carrying cost or holding cost. Q is the same batch size we put here. Z is a Z-score, which represents our service level, also called the cycle service level. So if the service level is 90%, that means that 90% of the time we don't want to be out of stock. We want to have enough stock to meet the demand from the stock. So you convert that 90% to a Z-score, and I'll show you how we do it in Excel. Okay. And then SDL is standard deviation of demand during lead time. SDL depends on how variable is your demand, okay, and how long and variable is your lead time. If lead time has zero variability, it is fixed. And if your demand has zero variability over time, it is fixed. Then SDL will be 0 and this whole term will be 0. Z multiplied by SDL is basically your safety stock. Okay, and this is your cycle stock. Cycle stock plus safety stock is average inventory level times HC gives us the carrying cost. Now the out of stock cost formula uses what's called K. This is the cost of having a stock out. So there are two scenarios here. When you're out of stock, either you lose that sale, which means the customer says, okay, I'll go buy from somebody else. And so that in those cases, K is usually the gross profit you would have earned on an item. Gross profit is price minus cost, usually landed cost. So if an item sells for $20 and it costs you $15 to bring the item to be sold, then your margin is $5. So K will be $5 per unit. Each time you have a lost sales, you lose $5 per unit. In some situations, you have back orders. A back order is customer comes and says, hey, I want to buy this item. And you tell the customer, I'm out of stock. Can you please wait 3 weeks? Once the stock comes in, I'll give it to you. And the customer is not willing, so maybe you give the customer a discount, maybe you give the customer a voucher to make them happy, maybe you have to expedite shipping, so you say, okay, I'll expedite shipping for you, it'll be here next week. So anything you have to do to make the sale happen in future, there's going to be some cost associated with that. That's called a back order cost, which means that you had to incur some cost to make that sale in future to the same customer. The customer is reserving the item for future delivery. Okay, so depending on the company policy or business context, you may have back orders, you may not have back orders. So K is either going to be the stock out cost by like a lost sales cost, or K is going to be a back order cost. K cannot be both. You either do one or the other. Okay, so whatever you are doing in that situation, K is going to be that cost of basically not being able to sell one unit from inventory. SDL again is standard deviation of demand during lead time. There's a whole slide on how to compute SDL up here. So this is how you compute SDL depending on what the variability looks like, right? And so I talk about this in the detailed lecture. You should recognize this if you have taken inventory management before in operations or supply chain management. EZ is called the unit loss integral. It is kind of like a z-score, but it kind of estimates what percentage of units will you have lost sales for. So if you are selling, are you going to have 2% lost sales out of all the demand that you see? Are you going to have 3% lost sales? It gives you like a proportion type of thing like that, and then you can convert that into exactly how many units you will have lost sales for. Okay. Now the last part of the formula is called the pipeline inventory cost. So this has the same H, the percentage carrying cost. Now this interestingly has C naught and not C. Okay, C is the landed cost. So if you remember this slide, we talked about C, the landed cost, which is C naught plus R, and C naught is what you pay to the supplier that does not include the transportation expense. So that's going to be C naught. Why? Because when the goods are being transported, you haven't paid the transportation company yet, so the cost of the item being transported is just C naught and not the landed cost of C. So you do H times C naught times annual demand multiplied by what fraction of the year does the item spend in transportation. So T is the transportation time. If it's in days, you divide by 365. If transportation time is in weeks, you divide by 52 because there are 52 weeks in a year. If transportation time T is in months, you divide by 12 because there are 12 months in a year. So you convert the transportation time into a ratio, okay, which is what fraction of a year does the item spend in transit on the way to your facility. Okay. That fraction multiplied by D times C naught times H gives you the pipeline inventory cost. Again, it's like a holding cost, like a carrying cost, but you carry this stock for a fraction of the year, not the whole year. Okay. So let's look at this example and look at how we can quickly solve this example in our Excel inventory cost calculation worksheet. So this Excel file has been uploaded, inventory cost template on Blackboard. The blue cells are input that you have to enter, and the gray cells are results of a calculation. Okay, so this Excel sheet, you have to enter some demand data. Okay, the demand data, you're going to calculate demand per year. The model automatically calculates that, but you have to give it demand per day or demand per week or demand per month. Okay, if you are working in weeks, you can give it demand per week, and then you can specify there are 52 weeks in a year. It will multiply the demand per week by 52 to get the annual demand. Okay, if you are working on monthly demand, let's say this was monthly demand, you would make it 12 to say there are 12 time periods in a year, 12 months in a year, and it will calculate the annual demand. So whatever time units you are working with. So let's look at this example here. Okay, we are working in days. Small d is the daily demand at the bakery and is the standard deviation of daily demand. So let's put in these numbers. My daily demand is 50. My standard deviation of daily demand is 20, and there are 365 days in a year. If your bakery is open for less days, let's say it's only open for 300 days, you can put in 300 days. So it depends on whatever days you're open for. Okay, so it says bakery is open 6 days a week for 52 weeks a year. Okay, so that means we have to put here 6 times 52. If we can just do 6 times 52. So my bakery is open 312 days a year, and so that's my annual demand. Then we have to put in lead time and transportation time data. Okay, so we are given that the bakery has a lead time of 4 days, takes the supplier 4 days. So we plug in, 4 days. Notice the units here, if it's days or weeks, have to match the units of small d. If small d is daily demand, this has to be days. If small d is weekly demand, this has to be weeks, and so forth. Okay. What is the standard deviation of the lead time? Um, let's go up and check. Okay. Also, in the question that we have here, where we are working on this bakery example, okay, um, the lead time is actually fixed. Okay, that's what the question tells us. So, how does it tell us? It does not specify standard deviation of the lead time. Okay, so we know that the lead time has a standard deviation of 0. Okay, so the example details are given in the slides, so you can look at that. Okay, so the lead time is 4 days. Carrying costs are 40%. Purchase cost is $2. So let's plug in this data. Okay, so transportation time is, let's look at transportation time. Well, in this case, the transportation uh, time is does not matter. Why? Okay, because if the supplier agrees to own the inventory during transit, then the pipeline inventory cost will be 0 for us because the supplier owns the inventory. And if the we own the inventory during transit, then we will have the transportation expense. So let's say the transportation time is 2 days. Actually, for this question, we should make it 0 because we don't own the goods in transit. So there's no transit time on our dime on when we own the inventory. So we just make it 0. But if you did have a transportation time where you own the inventory, then you would put in whatever days it takes to transport the bread from the supplier's factory to your warehouse. So let me put 0 for now, then I'll show you what happens when I change that. So the bread costs $2. The transportation rate is, does not, the transportation rate is given somewhere here. Okay, now so we're not given the transportation rate because we are not paying the transportation. We are basically getting the bread $2 delivered to our factory. Okay, because the supplier says I will give you delivery in this price. So this is going to be 0. So we pay the supplier $2. He takes care of the transportation in this example. So the landed cost will be 2. If we did have to pay the supplier, let's say 50 cents a loaf for transportation, we'll put 0.5 here for the transportation expense. Okay. Cycle service level is 95%. So you put 95. It automatically converts that into a z-score. It automatically calculates the EZ unit loss integral. Okay. The stockout cost is $1. That's what we lose, when we have a lost sale, like when we're out of stock. Okay. Now, what else do we need? We need to know the ordering cost. Inventory holding cost is 0.4, which is 40%. So 40% is $0.4 per dollar of inventory per year. That's the same thing as 40%. Okay. All we need now is the the ordering cost. Okay, so let's look here. Okay, so our batch size is 300. Fixed ordering cost is $5. Okay, so we go here. Fixed ordering cost is $5. Now, what this spreadsheet does, it uses the EOQ formula, okay, which is like an optimal batch size to calculate that we are going to be ordering in batches of size 441. However, due to maybe the truck that delivers the bread is not as big to carry 441 loaves or other reasons, the supplier takes orders of size 300. So what I can do is I can just copy paste this formula here to not destroy the formula and make this 300 because the question says we order in batches of size 300. Whenever the batch size or order size is specified, we enter that here. If it's not specified, we use the EOQ formula, which is this formula right here, to compute the batch size. By default, the formula is inside. You can always copy paste this back to replace everything, or you can just type the batch size that is given in the question. So, given the values we provided, inventory holding costs are $172.64, inventory ordering costs are $260, lost sales back order costs are $43.46. There is no pipeline inventory cost because the supplier takes care of the transportation as long as we pay the supplier $2 a piece, and these are our total inventory costs per year. Okay. Now, if you do the problem manually, okay, you would get a very close answer. Why would you not get the exact same answer? Because when people do the problem manually, instead of using, the z-score to 20 decimal places, they're going to just put in 1.65. They're going to round it down. They're going to round, off EZ, because in Excel, we're using these values to 20 or whatever, 15 decimal places. And so, and those are going to create a small difference versus doing the computation by hand. Even though the decimal places are not being shown, there's a lot of decimal places trailing these numbers that Excel uses in the calculation. So this is the exact cost without any rounding, but if you do it by hand with rounding, you'll get something like 475.7, which is almost exactly what we got. Now let me show you some variations. So let's say the supplier is not very nice. He says you have to pay for transportation. Okay, it's going to charge us 25 cents per transportation cost. So now our landed cost has changed. Okay, and let's say the supplier, it takes 1 day to transport the bread. So that's the transportation time. And let's say the lead time is on average 4 days, but it has a standard deviation of 0.5 days. So it's not always exactly 4 days. So you can change these numbers here to match that reality, and you can see your costs have gone up. You have pipeline inventory costs, okay, because of variable lead time. You have more lost sales now because sometimes the truck doesn't arrive on time. So everything is changing as we expect, and our inventory costs have gone up. Okay, now let's say the supplier says I've bought a bigger truck. You don't have to order in batches of 300 anymore. You can use your EOQ quantity, okay, to do the ordering here. Okay, so you can see from 556, when we use the EOQ quantity, our cost drops to $521. Okay, so that is how we can do our cost calculation. Now questions on the homework or exam might say, okay, give me the inventory holding or carrying cost, right? They might say, give me the carrying or holding cost. That is just this number. Don't give the total number if the questions only ask for this cost. Or the question might ask you for lost sales or back order costs, which is this number, not the total. So you have to understand what these four numbers are. You add these four numbers up, you get the total. Okay. Okay, so you have to understand these four costs, what they mean, and that the sum of them is the total inventory cost per year. Now, oftentimes we're interested in what happens to total cost or these individual costs as we change some parameter. Okay, so maybe we're gonna, let's say, let's go back to our situation. Let's say we were shipping in a truck where the amount of bread we fit in was 300. So we got 300 bread loaves at a time. That was our ordering size, right? And now we have an option that we could do LTL shipping, less than a truckload shipping. That's going to cost us a bit more. Maybe it's going to cost us, 40 cents a piece, but we could order smaller batches. Okay, or maybe we can pay 0.4 per piece and get a bigger truck and order bigger batches. So maybe you want to figure out how does the total cost vary as we change this batch size. So that's not too hard. Okay, our batch size is Q, and that's going to be our total cost. Actually, let's do this. We can do carrying cost. We can do lost sales cost. We can do all these four actually. Let's do all four. Ordering cost, lost sales, and pipeline, and then the total cost. Okay, so I can specify different batch sizes: 100, 150, 200, 250, and what we can do is we can kind of drag it down to see what's going to happen for different batch sizes up to 600. Okay, and I need an empty row here. Okay, so here I'm gonna use what's called a data table in Excel, because what you can do is this. Okay, you can put in 100 and then copy paste these costs here in front of 100. Okay, and save all the cost. Then you can put in 150, copy paste all these costs here, right? And do all of that. Then do 200 one by one. You can make this table of how the costs vary as you change the batch size. But we can automate that using data tables in Excel. Now, it's if you Google data tables in Excel or search it on YouTube, you'll find a dozen tutorials online. I'm going to show you how to do it. If you forget, you can watch this video again or just look at a tutorial online. So on top, so this is going to be my table. So let me just shade it so you know where my table is. Okay. And on top of your table, you're going to specify which cells Excel should copy. So just do equal and hit the cell that you want Excel to save the output of as Excel changes the batch size. And then we can select this whole table, go to data, what if analysis, data table. Because Q is in a column, the different values of batch size you want to try in a column, we're going to use column input cell. If these were horizontal, we would try row input cell, but our values that we're going to try for the batch size are in a column. So we do column input cell, and we specify that the values from 100 to 600 should be placed into this cell to make this table. And then you hit OK. And there we go. You can see that the batch size has no impact on the pipeline costs, but the other costs do change based on the batch size. We can format these cells so they look a little bit better. And now you can make all sorts of plots. You can do, insert, make a nice plot. Okay, now we're going to obviously select data to fix things, and series 1 is actually should be on the x-axis. Series 1 we're going to remove, and the horizontal axis is going to be the batch size. Okay, now series 2 is column E, which is the holding cost or carrying cost. So I can type that. The next series is the ordering cost. Okay, the next series is the lost sales cost. The next series is the pipeline cost, and the next series is the total cost. So now you can see over the range in which we changed our batch size, okay, the total cost came down, and then at very high batch size is starting to go up again. So if you went to about 1,000, you'll see it go up more, right? So you can see where is the minimum, because you can see it fell down to 540, 537. Okay, that's the minimum value. Then you start to go up again. So you can see all the costs, how they move with the batch size. This is a very powerful tool because you can make charts to show how your inventory costs change as your transportation rates change, as your lead times change. For different lead times you can do this. So this is a very powerful way to investigate how your costs move. Now, to conclude this lecture, let me go to this slide and kind of point out why are we doing all this work to work on inventory costs? Because often, your transportation cost, by the way, your transportation cost, you can also calculate. That's going to be your transportation cost per unit of R, okay, multiplied by your annual demand right here, okay. So this is your transportation cost in dollars per year, okay. Now, if you get, let's say, a supplier whose lead time is a lot more, okay, and because the supplier is far away, the transportation time is a lot more, and because the supplier is far away, the transportation cost is a lot more, but this supplier, well, maybe it's zero point 0.8, but this supplier is cheaper. You get bread for $1.5 a loaf. So you can see whether going for the cheaper supplier, that's going to reduce, that might reduce your inventory cost or might increase them, or what is your transportation cost. You can do all that analysis, what if analysis, what happens to your inventory cost, what happens to your transportation cost. You can compare different supply options, and you can do all of that. Transportation cost per year is the easiest thing to calculate. It's just how much you pay per unit to transport something, and the units you buy on average in a year is going to be the demand for a year. So that's how many units you actually transport on average in a year, and so that's going to be the transportation expense. So you can look at total inventory cost, total transportation cost for different options, different suppliers, different lead times, and kind of figure out what is best way for you to go with. Now, many logistics decisions are going to impact your inventory cost. Anytime your logistics decision changes the lead time, it's going to change the safety stock and going to change the carrying cost. So wherever you see SDL, SDL is a function of lead time. It's going to change the out of stock cost, because if the lead time changes, SDL changes. Okay, if the lead time changes, usually your transportation time is also changing. Why? Because lead time includes the transportation time, right? Because what is lead time, right? Lead time is when you placed an order with the supplier, you start the clock. When you receive the order, you stop the clock. Part of the lead time is actually transportation time. Because if the lead time is let's say 1 month, the supplier may have taken 3 weeks to build your order, and then may have shipped it, and the shipment may have taken 1 week to arrive. So part of lead time is transportation time. Yeah. So if your lead time goes up, usually your transportation time would go up too, and your pipeline inventory cost would go up. Okay. What if we get a supplier which has higher minimum order quantities? Your queue is going to change. You're going to order bigger batches. That means your ordering cost will change, your carrying cost will change, your out of stock cost will change. So depending on how we choose the suppliers, what transportation decisions we make is going to impact our inventory costs. And using this sheet, we can quickly calculate, current scenario inventory costs, new scenario inventory costs, and do a comparison on what works best for our company. Okay, so hopefully, you now know how to calculate total inventory cost per year. You can use this Excel workbook on an exam or homework. If you don't understand what these things mean, you can watch the detailed lecture. You should have a conceptual understanding of inventory cost. What do these terms mean? What are these four costs? What increases this cost? What decreases this cost? You should know that. Then you should know how to use this workbook, and then you should know how to use data table to kind of make a chart or a table which shows how the total cost varies as you vary any parameter. You could be varying Q, you could be varying the cycle service level. By the way, if you want to vary the cycle service level, don't put in 95, 96, 97. This is only formatted like a percentage. Okay, the actual value is 0.95. Okay, so I hit this, so it looks like a percentage, but the values are 0.9, 0.91, 0.92, 0.93, 0.94, like that. So here, for example, I'm showing you how do you change this percentage here, going from 70% or zero point 0.7 to 99.9%, and how your costs are changing, okay, using a data table. So just remember, even though it says percentage, the actual values are probabilities 0 to 1 point 7, 0.8, 0.9, like that. And so those are the values you need to put in the data table when you construct your data table if you're going to vary this parameter. Okay. Okay, so hopefully you're all set to calculate inventory costs and look at the impact of logistics decisions on inventory.